Okay, thank you everyone for joining us this evening. My name is Autumn Crow. I'm the Program Director of West Virginia Rivers Coalition. And we also have Mariah Clay, the Mountain Valley Pipeline Organizer. And we are going to be talking about the Mountain Valley Pipeline's impact on the Greenbrier River and how citizens can monitor that construction and report potential pollution. Now, if I can just figure out how to advance the slides. And please go ahead and mute. There we go. Okay. So the Mountain Valley Pipeline is proposing to bore under the Greenbrier River. The boring method entails drilling a borehole under the stream bed and running the pipe that borehole. There are 3 different types of borings that they're doing along the route. There's conventional bore, micro tunneling, or direct pipe. And then horizontal directional drilling. The advantages of boring is that the stream bed remains intact. But the disadvantages are that it requires a large amount of water and drilling mud or bentonite clay. There's a possibility of a bentonite blowout or a frack out or inadvertent return. It's labeled different things in the industry. And then there can be a failure of a dewatering device, and I'll explain what that is. There's also a possibility that the drill bit could get deflected from a large boulder. So the boring process, there are 2 bore pits that are constructed, one on each side of the water body, the bore pit and the receiving pit. And these pits are excavated to the depth needed for the pipeline to pass under the stream channel. A boring machine is then lowered into the pit and drills a borehole under the water body using a rotating auger. The pipe is pulled through the bore pit to the receiving pit. And this is an example of the schematic for the Greenbrier River crossing. So if you can see my arrow on river left is the excavated bore pit where the boring will occur, and then moving through under the river to river right to the receiving pit. So Mountain Valley Pipeline is planning to use the direct pipe boring method. This is a micro tunneling boring machine that's installs the pipe in one single pass. So this method uses lower pressure than the horizontal directional drilling, but the drill bit is subject to deflection from cobbles or boulders that are greater than 14 inches. And operations must continue nonstop to prevent the tunnel from collapsing. Also requires 1 million gallons of water mixed with a bentonite clay slurry that's used to lubricate the drill bit. So for the Greenbrier crossing in particular, there are several problem areas where construction could go awry and issues could occur. They're boring 1,250 feet diagonally under the Greenbrier River, 13 feet below the river bottom. Like I just mentioned, they're using 1,000 gallons of water that's going to be withdrawn from the Greenbrier River, mixed with that clay to lubricate the drill bit. The bore pits will be approximately 10 to 13 feet deep and 20 to 80 feet in length. So at the starting pit, it's going to be 20 feet in length, and then the receiving pit would be, the starting pit would be 80 feet, and the receiving pit would be 20 feet in length. So those are quite large pits. Pumping to dewater the bore pits will be required 24/7, and has potential to exceed the capacity of the dewatering devices. So that those bore pits are going to be under the water table. They're going to fill with water, and then pumping will be needed to dewater those bore pits. Like I mentioned, the drill bit is subject to deflection from cobbles and boulders greater than 14 inches. So that means as they're drilling, if they hit a big boulder, it could steer the drill bit in a different direction. And the bore paths extends through zones of fractured bedrock. We're talking about limestone and shale bedrock, and there are fractures within those bedrocks. The fractures, if the clay gets into those fractures, there could be a frack out or a bentonite blowout or an inadvertent return. So the clay could actually fracture through this riverbed and enter the river. And then this process will take up to 4 months to complete. So that's 4 months of continuous construction. So the best management practices that will be in place during this construction, they're going to be excavating a lot of soil to dig those pits, and the soil is going to have to be stockpiled along with the drilling cuttings. So those piles of soil should have a protective cover on those spoil piles, like hay or mulch or vegetative matting, because if the precipitation is able to interact with that soil, then it's going to cause runoff and erosion, and that will be harder to control. So that stockpile of soil has to be covered to prevent any precipitation from interacting with that soil to create muddy runoff. I also mentioned the dewatering devices. So that all of that water that's pumped out of those bore pits is going to have to be sent somewhere. It cannot go back directly into the river. So they have these dewatering devices that allows the sediment to settle out of the water, and then that clear water can slowly discharge into the upland area, so it's not discharging muddy water directly into the river. And that dewatering device is, there's a picture of it here that's in their plan. So there's a sediment dewatering bag within the center of the structure, and then there's 2 rings of straw bales with geotextile fabric. So that's going to contain, it's designed to contain all of that muddy water to keep the muddy water from entering the river. And then there's some drainage socks placed on the outflow area. So potential impacts from borings. Mountain Valley Pipeline has already done some borings along the route in West Virginia, and we've seen those go wrong. As I mentioned, the groundwater enters the trench or the bore pit and produces the sediment-laden water. They pump that water out into a dewatering device. But if those devices are not sized properly, or they're not designed properly, they're not built properly, then they're subject to failure. And that would release sediment-laden water into the stream or river and create a violation of water quality standards. There's also a possibility with all of the drill cuttings and the soil that they're excavating. There's a possibility of improper handling of that, or not having the proper BMPs to protect that. And if precipitation interacts with those drill cuttings or soil piles, then there's a potential for runoff and sedimentation and erosion. And then the clay slurry mix that is going to be used to lubricate the drill bit, that there's a massive amount of 100,000 gallons potentially of this clay slurry. And we've seen on other pipeline projects that slurry can easily get out of hand and pollute a wetland or water body. So all of that is going to have to be handled properly. And I mentioned this earlier, the bentonite blowout. So that is if there is a fracture in the bedrock when they are doing this drilling under the river with all of this bentonite clay. If that bentonite enters a fracture and is able to release into the water body, that's what's called a bentonite blowout, or an inadvertent return, as it's known in the industry. So with that, I'm going to hand it over to Mariah, and they can explain how we at West Virginia Rivers have developed this StreamWatch app that can help citizens report potential pollution as they are observing the construction out in the field.
Thank you, Autumn, for sharing this information. I know we're all eager to learn about. Good evening, everyone. Thanks for joining us today. I'm Mariah. I'll be guiding you through how to visually assess pipeline construction on the river using this 123 app. Before we dive in, let's ensure we have everything you need to get started. Here are what we call the guidance docs. These are very helpful, and I'll be referencing these throughout this webinar and walk you through step-by-step how to download the app and submit reports. Next slide, please. To begin, let's get you set up with the necessary tools. First, make sure you have the Survey 123 for ArcGIS mobile app downloaded on your phone. And you can do this through taking a picture of this QR code on top. All you need to do is open the camera app on your phone, point it right at the QR code, and it should bring you to a link to download it directly on your phone. And if you have an Android device, sometimes it makes you download a separate QR scanning app to do that. And I'll give just a moment to let folks do that if you want to follow along with this process. So once you've downloaded the Survey 123 app, what you'll then do next is scan the second QR code underneath it, which is what will take you to the West Virginia StreamWatch form. And that will allow your submissions to come directly to us. So I'll give you just a moment to download both of those. All right, next slide, please. When prompted, click the Open in the Survey 123 Field app. And once you do that, this is a crucial point. The app will ask for access to your location. It's essential to allow this because it enables the app to geolocate your submissions accurately for us. This ensures we know exactly where potential disturbances are occurring along the Greenbrier River. Also, there is no need to sign in. You can click continue without signing in, and all submissions will be saved onto your app even without signing in. Next slide, please. And once you've got those downloaded, we can talk about the types of disturbances we're looking for and how you can submit them. There are 6 categories: sedimentation and erosion, water quality impacts, solid waste, in-stream impacts, fish passage barrier, and other. Next slide, please. And we'll start with sedimentation and erosion. Most of you know sedimentation occurs when soil particles are washed into the water, impacting aquatic life and water quality. Here are some examples we have pictured here. These are disturbances under each category with photos, so you know what we're talking about. Each picture has sediment and laden water entering stream, failed erosion control, sediment on the roadway, sediment in streams or wetlands, and slope failure are all pictured there. And moving on to water quality impacts, these can have severe consequences on the ecosystems. And these examples include acid mine drainage, algal blooms, petroleum spills, and potential fish kills. Also pipes discharging pollutants into the stream, which you can see pictured there. The next is solid waste. This can include litter in the stream, open dumps, tire dumps. Each of these disturbances can harm the environment and wildlife in different ways. Some disturbances you might encounter are not directly related to Mount Valley Pipeline construction, but they're still important to document and submit. In-stream impacts, these are crucial to monitor. We look for equipment in the stream and also things like livestock entering the water. Environmental regulations often restrict the use of heavy equipment in streams to prevent sedimentation, erosion, all these things that cause habitat disturbance. However, some permits may allow for a single pass of equipment in streams under specific conditions. This one pass rule typically permits equipment to enter the stream to place construction materials like timber mats, which I'm sure you all have seen and are familiar with. And we also have fish passage barriers. They're very concerning for aquatic life. These include perch culverts and dams that hinder fish migration. Identifying and reporting these is crucial to preserving our river's biodiversity. Moving on to capturing good photos. When submitting disturbances, it's important to capture clear and relevant photos. Good photos help us understand the situation better. Examples of good and bad photos are shown on the slide. So in these examples, we have a good photo. It's showing us the report. It's showing us good perspective. And the bad photo is a close-up of something we can't really tell what's going on. So when you're submitting these photos, we want to have multiple perspectives, zoomed in, zoomed out. Think of us on the other end. We need to have good context of what we're looking at. And documenting pollution sources. Remember to document and photograph the source of the pollution. This provides vital context and helps us address the issue effectively. So in the picture on the left, we have source of sediment pollution, and on the picture in the right, we see the pollution, but we can't identify the source in that picture. So hopefully that gives you context of what we're looking for when you're out in the field doing these submissions. And here are examples of photos with different perspectives, like I mentioned earlier. When you're submitting these photos, it allows you to do multiple, at least 3 or 4. So each submission, take multiple pictures from multiple perspectives so that helps us and it gives us context as well. And we can take any questions you have about boring or the boring process or about the app as well. I know I see in the chat some people did not get to download the app, wasn't near my phone. Someone else said same. If you need help with this in the future, my contact is right there on the screen. I'm always happy to help you with this process.
Okay, so I know that was a lot of information, and I saw some questions coming in. So let's start with those questions that are in the chat, and then if you have additional questions, you can drop them in the chat, or once we get through these questions in the chat, there'll be an opportunity for you to unmute yourself and also ask some additional questions. So yes, it's 1 million gallons of water that is approved to be withdrawn from the Greenbrier River. So that's 1 million gallons, not 1,000. Million. Okay, that was already answered. What other questions do we have in the chat? Okay, yes, we can provide a copy of the slides along with the recording, certainly. And it is being recorded, although I can go ahead and stop the recording now. So we just have the presentation. So we'll go ahead and